Hello everyone. In today's lecture, we'll be talking about analysis and validation, and we will see that what are the different ways in which you can analyze a file in digital forensics, and also look at some validation techniques. What are those? And then in the later half, we will be talking about the different data hiding techniques and how you can find that. So if you guys are interested, it is the chapter in reading the book. It is the chapter number 9 in our course book. So the objectives, as I mentioned, first half, we'll be looking at what are the different ways or what are the different locations in which we should be looking at in a file or in a hard drive when we are doing our digital forensics. We'll be talking about the complete process from data acquisition to analysis, that what guideline you should use. We will explain some techniques that we use for validation. We'll be looking or focusing on hashing. And then the last part is the data hiding techniques. What are those? How people hide data and how you can recover them or how you can retrieve them. So the first question that comes into your mind whenever you are doing some digital forensics or whenever you are analyzing a case is where to start. What questions should I answer? What are there? What is the law enforcement looking at? What artifacts do I need to find in order to solve this case and so on? So all of these questions, like, what data to collect and analyze, it depends on the nature of the case that you are working on. So if you are working on a criminal case, then you will have a search warrant from the law enforcement. They will get it from the court. So your questions or what the police is looking for or what the law enforcement is looking for will be defined in the search warrant. So for example, if the law enforcement is working on a case related to email extortions, that somebody is like sending emails demanding money from other people, then in that particular case, your focus should be on email files or say browser content or those type of things, network connectivity or those locations or regions in your suspect's computer that will lead you towards your case or towards the questions that are posed by the search committee or the you can say the law enforcement here, that we need to know whether this person was sending the extortion emails from this PC or not. In case of civil cases, this is defined by the court order. So if there is some say intellectual property dispute between the two companies, both of them claiming that the movie or the picture that is their own. So in those cases, court will hire you and they will give you that we have this case at hand and we want to determine who's the rightful owner. So in that case, whatever is whatever artifact is at stake, you will be focusing on that particular artifact in the suspect's drive. The last thing is, in case of private investigation, if a private company hires you, for example, an employee of company X is using company resources in order to do his own business. So he comes in office and rather than doing company's work, he starts doing his own business online. So in that particular scenario, the questions or, the location or what you want to analyze, what data you need to collect, what things you need to analyze, all of that would be dependent on the private investigation, on the private company, and they will give you or a set of questions that they need answers for. So in all these cases, whatever you want to look, the locations in the PC or suspect computer that you want to analyze, and what type of questions you want to answer, they will be determined by the search warrant in criminal cases, civil cases by the court order, and in private investigations, then whoever is hiring you, like the private company, they will give you these set of questions. So whenever you start your forensic investigation, the first thing is to determine a scope. So what is a scope? That you are, for example, if I look at the previous slide, you are hired to do forensic investigation. You are given a set of questions or locations or proofs that the law enforcement agency is looking for. Depending on that, you make a list of questions or you can say a list of locations that you want to look. So that thing will become your scope or the scope of the entire investigation. As the example, like for example, if we take the extortion emails case, then my scope here would be that I want to look at the files or artifacts in the suspect's drive that are related to emails. So I will be doing mainly email forensics. I will also be looking at the browser of the user. I will also be looking at the temporary internet files and so on. So I will list that down and determine or create a scope of the case that this region or this set of questions I need to answer. And this should be my, you can say, I will also narrow down the artifacts from the suspect computer as well. For example, if I'm looking at the email related case, I will only be focusing on the artifacts that are related to the email. I will not be looking at, say, what are the other files like the pictures or images that might be there on the suspect's hard drive and so on. So sometime what can happen is that even though you determine or you develop this scope early on at the beginning of the investigation, sometime it can happen that, while you are doing investigation, you found some other piece of evidence that deviates you from your original scope or from your original target. So we call that in digital forensics as scope creep. That means you were working on one thing, you found an unexpected evidence, and now your investigation is turning toward that new unexpected evidence that you found, and you will spend more time on that. So scope creep is generally discouraged. Why? Because if you divert your attention on the newly detected or newly found evidence, then you will be wasting a lot of time as well as a lot of resources on that new direction of your investigation. And it is also possible that, this new direction that you have taken, it is totally irrelevant to your main case as well. So depending on this, we don't want to waste resources. Time is crucial, resources are crucial. So we try to stick with the scope of the investigation that we have initially determined. Another thing is sometimes in order to do the analysis on this new piece of evidence, you might need some new legal documents such as new search warrant, or you might need permission from the court in order to access those new pieces of evidences. So scope creep is highly discouraged in digital forensics, and it is always a good idea that if you want to if you like find a piece of evidence that you feel is so crucial, talk to your lawyer. So all the digital forensics firms, they have lawyers on board as well. So talk to the attorneys, and then if they see or if they tell you that yes, you don't need any legal, uh, you know, uh, uh, statement from the court or any legal permission from the court in order to start the new investigation, you can go and you can start looking into that. So with that thing in mind, now let's talk about what are the things or what are the guidelines that you should follow when you start your case. So the first thing that we need to do in every case is that we need to collect evidence. And how do we do that? We go to the suspect system, and then depending on what type of access we have, we start making copies of the suspect's data on our own hard drives. So our own hard drives that we are using, these are called target drives. So the first thing that you should make sure is that the target drives or the hard drives that you are using to copy the data from the suspect's machine, they are wiped out. By wiped out mean there is no lingering data from any previous case. They are clean. There is no data in those files. They are sterilized as well. So what does sterilization mean here? That there is no virus or malware or anything on those hard drives that might corrupt your the suspect's data or might corrupt the data that you are gathering in this particular case. Another thing after doing that is to create an inventory of the hardware on the suspect's computer. So for example, how many hard drives were connected to the suspect computer, if there were like any USB drive on the table, or if was there like any like flash card or something like that. So whatever the hardware data, the hardware artifacts that you see over there, hard drives, USB drives, flash cards or memory cards, and so on. So you list all of them and on a piece of paper or on your report, and then later on when you are doing your analysis, you will go through all of those data mediums one by one and do your analysis on that. Why do we need to list them? Because sometimes it can happen that you went to the suspect's location, you saw 5 USBs there, but you forgot to, copy the data from one of them. So it is always a good idea that whatever data medium you see there or whatever hardware you see at the suspect's location, make a list of all that, take photos or keep create other form of different uh, data as well, and make sure that you have a complete view or a complete list of all the things that you saw there. Then if you are doing like static analysis and you need to pull out the hard drive, make sure that you see the system time using CMOS. So CMOS we learned earlier when we were talking about the window forensics and Macintosh forensics, Mac or Linux forensics. So CMOS is like a component on your motherboard that keeps important information that is needed in order to boot the system. It also keeps a record of active system time as well. So before you plug in, the hard drive from the motherboard, make sure that you have the valuable information that is stored in the CMOS. Make a copy of that as well. And the last thing is, while you are doing all this process, you have to write it down that what process you followed. For example, you will create a document that would state that I went to the suspect's location. I found there 4 or 5 different USBs. The suspect had a hard drive of total with a total capacity of 1 TB, and like there were 2 partitions inside it, and so on. So all the things that you are doing, all the stuff that you see over there, all the steps that you are doing in order to acquire the data, you have to write everything down. So now the next part is, okay, we have the data, what's next? Now we're going to start the investigation part or the analysis part, and we'll be looking at what are the things that you need to look at. So the very first thing is to make a copy. So whatever the data that you acquire, make multiple copies of it. Take hashes of that as well, like all the hard drives that you, all the data that you collect. Uh, Compute a hash of that and store that hash along with the data copies, so you know that later on if you want to validate whether the data is corrupted or not, you can look into the hash. So when you start investigating the files, investigate them, or the contents of the hard drives methodologically and logically. So what does that mean? So just imagine you copy the data from the suspect hard drive, and you copy data equivalent to say 1 TB or 2 TBs. So now in 1 or 2 TBs, there could be thousands of different files that are there on the suspect's hard drive. So would you like start, investigating all of them one by one? The answer is no. Why? Because we will look back into the scope of our investigation. If my investigation is related to email forensics, then a good technique is to first focus on the files or the artifacts that can help me solve that particular case. So I will be looking at the temporary files, I will be looking at the browser files, I will be looking at the email files, and doing other sort of things that will help me solve the email case. If my case is just assume related to child pornography, that there was the suspect was selling some illegal images on the internet. In that case, my focus will be on the JPEG files or the image files that are there on the suspect's drive. So those type of files will be on my top of my list, and they will be my priority. So every time you start investigation, do it, create a method. So your method will be related to your case, your logic should be related to your case. So what type of case you have at hand, try to analyze the files that are most relevant to that particular case. The next thing is listing down all the files and folders. So whenever you like start your investigation, just create a list of all the files and folders that you see on the suspect hard drive. Why it is important? Because as I mentioned earlier, if there are thousands of files or hundreds of different folders that you found or retrieved from the system, accused PC, then you need to have some, like when you are doing your investigation, it is possible that you unintentionally skip 1 or 2 folders among 100 folders. So it's always a good idea to create a list of all the folders and files that are there. And then when you want to start investigation, create like a method, create a hierarchy of those files, which files you want to look first, which files you want to look second. And then every time you investigate a file and the investigation is done, just mark tick on that particular list. So there is a very low probability or low possibility that you will miss any important file or any important folder over there. Now, the next thing is we have listed down or we have narrowed down the files or folders that we want to look first. Then we will start looking at the content of that, list of files and list of folders. So one by one, we will be opening the files that are related to our case. We will see what is in there. So for example, if I'm looking at image file, I will double click on that image, open the image and see what is inside that image. So for example, if it is related to child pornography or something else, I will have to open the image and see whether the image actually is related to the case or not. Because sometimes it's possible that you can have hundreds of different images. Some of them will be related to your case. The others might be benign photos of the suspect, or maybe, like his house or flowers or garden or anything like that. So after, narrowing down to the files or folders you want to look at, or the ones that are related to your case, you will examine the content of those files and folders one by one. The next thing is there is always a chance that you will see files that are password protected, or the files that are, locked by the user. So in that particular case, then you have a challenge of recovering the data from them. So in that case, we will look later on in this chapter or in this lecture, that what are the different ways in which you can uh, extract the content of password protected files, or what are your options there. But if we find some password protected files, then it is our responsibility to try our best to retrieve the data from them as well and examine that data as well. Then we can find a lot of executable files on the suspect's machine. So for example, executable files are your program files. Every program has an executable file. So we will need to find, or filter out the known good executables from the known bad executables. What does it mean? So if you look at your computer, there can be hundreds of different executable files that are there. So not all of them are going to be bad files. Some of them are very common or very well-known executable files. For example, all the programs that you have in a Windows PC, say Paint, Microsoft Word, Microsoft Excel, all of these programs, they have executable files. And these executable files or these programs are very common and very well known. Like all the PCs that have window, they all have paint program or paint.exe. So if you see a file with the paint.exe, is there, then that is a benign file. You're not gonna, spend time on looking at that. You can just filter out the known good executable files from the entire files, and then whatever files, executable files are remaining, they should be on your top of the priority, or you should be focused on them first. And then after that, if you don't find anything, then you can look into the known good files. And last thing is to maintain a control of all the evidences and finding. So this point relates to the chain of custody. So from the moment you get this data and you are doing your analysis, you want to make sure that no unauthorized person get access to that data. And every time this data exchanges hands, you have to write it down in the chain of custody document. So I mentioned earlier that once you have identified or defined your scope at the beginning of your investigation, you have to stick with it and you should avoid deviating from that scope or avoid the scope creep. But is it always the case that the scope creep is bad? The answer is no. Sometimes, even if your initial plan, no matter how good or how sound it is, you might find some evidence that is directly related to your case, but it somehow deviates you from your main investigation. And a perfect example would be that I am investigating, emails of a suspect that he might have sent for, say, extortion. And then in one of the emails, I see a file, say, client list.txt. So now client list.txt, it is a text file. I originally thought that I will be looking at the files or folders that are related to emails, such as the browser content, the temporary internet files, and so on. But now, since the suspect has mentioned this client list.txt in his one of his emails, then I will have to look into this file client.txt and see the content and analyze it. So not always is that the scope creep or deviation from your original scope bad. Sometimes it is necessary that you have to take it, but most of the time we try to stick with it as much as possible. So after doing the analysis part and collecting the data, doing the analysis, the next thing is data validation. So what is data validation? Why it is important? What are the different things that we can use to validate the data and so on? So let's discuss them one by one. So data validation is very important. It is mainly used for ensuring the integrity of the data. So for that, we mostly use tools that allow us to create hash of the image file that we get from here. The image file here doesn't mean your picture files. It means the content of the hard drive, like we image the hard drive or we take a snapshot of the memory contents. So whenever we acquire the data, in order to validate the data, in order to preserve its integrity, we use the hashing algorithms. Most of the tools that we use, such as Autopsy, FTK Imager, and so on, they do provide us some form of doing the hashing all the time. When we acquire the data, they create or generate a hash of that data as well and append that in the file. Some formats such as EO1 and AFF Smarts, they also provide the data hash automatically. We don't have to do anything ourselves. But sometime if the tool doesn't do it automatically, we need to open this file or this image into some other tool such as a hex editor and then take that hash manually. So most of the tools that we use commercially, such as the FTK Imager, such as the Autopsy and other things, they automatically do the hashing for us. So in Autopsy, for example, or in FTK Imager, in both of these things, every time the first time you take the document in FTK Imager, it will take a hash of that original document and append it to that file itself. Now, every next time when you try to open that file, it will take a hash again and then compare that hash with the original hash. And if the two match, then all good. Otherwise, it will give you the indication that some tampering has been done in this particular file. So most of the time, the validation part is automatically done by the digital forensic tool that you are using. But somehow, if you're using a tool that doesn't provide that, or there is some other issue, then you will have to manually do it periodically in your investigation. That when you are doing investigation, maybe every day or every other day, just compute the hash of your artifacts just to make sure that there is no tampering. If there is any tampering, then you will have to refer back to some other working copy that you might have created in the first state. So as I mentioned, some tools might not have this feature. So in that case, you will have to use other programs such as WinHex or any other hex editor, and then take or compute the hash manually, store it somewhere on your own PC, write it down, whatever, however you want to save that file. But you have to create or maintain the hash of your artifacts at different intervals and always compare them with the original one just to make sure that there is no corruption of the data and the data is still valid. So here is an example of WinHex. I showed you earlier this tool as well. So it is a hex editor. You can use any hex editor of your liking, and you can just take a hash and store it on your computer and then always compare it with the original file. So hashing, there is another useful case of hashing as well. So one case that we just discussed is to validate the data or to make sure or to preserve the integrity of the data. Hashing can also be used in order to search for the data as well. So for example, if I want to find out whether, say, image.jpg or say, just like refer back to the other case, client.txt file that the client might have, the suspect might have sent through an email, whether that file exists on a PC or not. So it is possible that, in order to hide the file or from the forensic investigators, the suspect might have changed the name of that file or the extension of that file and so on. So sometimes what we can do is, rather than finding the files by their name, we can also use the hash. So if we have a known file, we can create the hash of that file, and then we can compare that hash with the hash of all the other files like that are there on the system. So if you have 10 files, no matter what their name are, what their extension are, open them in WinHex or any other editor, take the hash of it, you will get a list of all the hashes, and then whatever the known file or the file you're looking for example, client.txt, take its hash and then compare the files on the basis of hashes rather than comparing or identifying a file on the base of file name. Another important thing in hashing is blockwise hashing. So what is blockwise hashing? Why it is useful? Let's look into that. Sometimes it is possible that the file that you are looking at, the suspect might not have that exact file as one copy, but in fact, the suspect, dissolved the file or distributed the file into three different files. So, and then stored them with different names. So now if you try to find the complete hash, try to compare with the hash of all the content that you have on your hard drive, then you might not get a one-to-one match. So what we do in that case is most of these tools like WinHacks, they provide you with the capability of blockwise hashing. So what blockwise hashing does, it divides the file into different blocks. So we can say sectors or clusters at the hard drive level, and then compute the hash of each cluster or sector one by one. So if that happens now, for one file, you don't have one hash that hashes the entire file, and instead you have different sectors or different clusters of that file, and you have hash of each cluster or each sector. So you divided your data into different blocks or into different clusters and then computed the hash of each individual block. Now, since you have divided your data into smaller parts, you can look into the hard drive for those smaller hashes. So even if the suspect has divided the file into multiple blocks and stored them, on different locations on your hard drive, you will still be able to find whether the file is there or whether any block of that file is there on the suspect's hard drive or not. Another way is that, sometimes we have files, we delete them later on, and some of the file data still remain in the hard drive in the form of slack space and so on. So with blockwise hashing, if we find like we create different blocks of the target file, create hash of that, and then, create hash of all the clusters that are there in a hard drive. So if any of these block hash and the cluster hash matches together, then we would also know that at some point in time, this suspect had the file, the target file that we were looking for, but later on he might have deleted. That's why we don't see the entire file, but we see the remnants of the file. So using the blockwise hashing, you can identify, or you can find that out whether the suspect had the target file at any given time or not, even if he or she might have deleted that. So the next thing or the next use case of hashing is data discrimination. So what is data discrimination and how we do that? Let's look into that. So data discrimination is that if you have 1,000 files in a suspect's drive, you don't investigate them equally, or you don't give the same weightage to all of those files. So what we would do, or what we do in data discrimination, is that if we have 1,000 files, we divide those files into three categories: known good files, known bad files, and unknown files. So how do we identify, or how do we categorize these files? So what we will do is, for example, if you take the image of a suspect machine, you can go into Windows. There will be tons of different DLL files that are there on every Windows computer. So these files, DLL files, system files, window files, all of them, they are most of the time benign files, and they are very common and very popular, and you can find them on all the PCs that run Windows. So we can label these files as good files, right? The next category is known bad files. So if you guys remember from your lab where we were talking or looking into malwares, I mentioned VirusTotal. So what does VirusTotal do? VirusTotal has, a known database of bad files, and whenever you want to search whether a file is good or bad, you just upload that file on VirusTotal. It compares that file with the database that it has, and see whether it is, your file that you have uploaded, whether it matches with the known bad file or not. So we could do the same thing with hashes as well. We can use something which we call the known file filters, or KFFs. So most of the forensic tools, they have these KFFs or known file filters built in. For example, the access data has a KFF file built in the autopsy that you can use. Also, FTK Imager has a known KFF file filter available on their software. So what you do is you like get the files. So we got 1,000 files from the suspect's machine. we took the hash of all those 1000 files, like individual file, take the hash of individual files, store it somewhere, and you will have a list of 1000 hashes. Now, among these 1000 hashes, we will search into this known file filter. It will contain some hashes or some files that are benign. So for example, all the window DLL files or all the window files that are benign files, we will match their hash. So if the hash of a given file matches with the known good file, we separate that out. If it matches with the known bad file, then automatically it is a red flag. So we categorize it as a bad file, and we can look into that later on. The third category is unknown files. So if any file doesn't fit into known good or known bad, then we will give it a unknown classification. So this way, rather than analyzing the complete 1000 files that were there on the suspect's drive, we did a data discrimination, or say file discrimination. We divided the files into three groups: good files, known good files, known bad files, and unknown files. And then we can start our investigation with known bad files. We will look their content first. Then we will be looking into the unknown files. And later on, if we are still unable to solve that case, we can start our investigation and we can look into known good files. So this process of data discrimination can save you a ton of time and resources, rather than analyzing all files equally or treating all files equally. Just compare the hash of the file with the database that you have in known file, in the form of known file filters, and just distribute or divide the files into different categories. And then you can, depending on the category, look at the bad file first, then look at the unknown files, and lastly, if the case is still pending, look at the good files and see if there is something missing over there. So data discrimination using hash. So all the tools, as I mentioned, Autopsy, you can look into the user documentation of Autopsy, how you can use this data discrimination. Access data has KFFs, access data known file filters, that you can plug in into the FTK imager. I think version 6 onwards has these things built in. There's also a government or official website, which is called National Software Reference Library, or NSRL. So if you go to the website of NSRL, over there, you can find these lists of good files and bad files as well, like the hashes of good files and bad files, that you can compare with the hashes of the files that you extract from the user's machine. All right, so we have so far looked into different use cases of hash algorithms or hashing. So we looked into data discrimination, blockwise hashing, hashing for validation. So a lot of uses for hashes. But are hashes perfect, or like, is there any way that the hashes can be broken, or all they always good? The answer is no. Why? Because if you look at the hash, what we do in a hash is that we give a hashing function a plain text, and it generates a hash or a digest, which can be n bytes long. For example, if you look over here, these are the hashes that different hashing algorithm produces. So if you give MD5 any word, any file, anything, it will give you a hash that will be 128 bits in length. Similarly, SHA-1 will give you a hash which is 160 bits in length, and so on. So what that means is that you give it a file and it produces a hash. So sometime what can happen theoretically is that two different files that have totally different content might produce the same hash. So this phenomena is called hash collision, that rather than having a one-to-one function between the plain text file and the hash of the file, you have two files that produce the same hash. So if that is the case, then most of the things that we discussed earlier, data discrimination, blockwise hashing, and validation, all of them will be in question. Because if two files can produce same hash, then it is possible that you're looking for file X, but you found file Y, which is not related, or which to your case, and doesn't prove anything. So hashing is not always perfect. It has issues as well. And the issue is called data or hash collision, that two different files might produce the same hash. So looking into further into that, why does this happen, or why we see data or hash collision? So if we look into the hash function, or how it works, is that we give a plain text to the hashing algorithm, and the hashing algorithm produces a hash. Now this hash is of n bytes, right? We saw in this case that MD5 produces a hash of 128 bits. All right. So if the hash is 128 bits, what's the maximum number of different hashes that MD5 can produce? The answer is that each bit can be 0 or 1, and the total number of hashes that MD5 can produce is 2 to the power n. So even though 2 to the power n looks like a very large number, for example, in case of MD5, it will be 2 to the power 125, 128, which is a huge number, but still it is not infinity, right? So here, on the other hand, or the right hand side, the plain text files can be unlimited. For example, it could be a text file, it could be a word, it could be an image, it could be a movie, it could be a sound file, it could be a window file, and so on, so forth, right? So there is no limitation in the plain text files that you can give to the hashing algorithm, but there is a limitation on the number of different unique hashes that an algorithm can produce. So even though this number might be very large, but still you will see collisions. So that's why if you look at this table, the algorithms that produce bigger hashes, they are more secure and they are more prone to the hash collision. So if we compare MD5 with SHA-1, MD5 produces 128-bit hash and SHA-1 produces 160-bit hash. So SHA-1 can produce more hashes, unique hashes as compared to MD5. So if we are to break these two algorithms, MD5 will break first and then SHA-1 will take a lot of time after that to produce a collision. So in fact, the MD5 algorithm, it was broken in 2004, and SHA algorithm is also like, broken theoretically, but with the advancement of quantum computing, we will see in the next decade or so that most of these or some of these algorithms that we see secure now, hashing algorithms, they will be broken, they will start colliding, or we will see hash collision with these algorithms as well. So with this limitation of hashing algorithms called hash collision, are they still useful? The answer is yes and no and maybe, like both of them. Why? If we are looking at encryption, then we saw that MD5 is broken, SHA-1 is also theoretically broken. So if we use these algorithms for encryption, it is very much possible that some attacker can just use quantum computing, or say cloud computing, or any other high intensive computing mechanism to break these passwords. But for our cases, for digital forensics, where we want to mainly look for the integrity of a file, or for known file identification or file data authentication, it is still useful, because no matter how big the hard drive is, we're not going to find 2 to the power 128 files on one suspect's drive, right? So it is possible that in our case, it is impossible that the hashing algorithm, or we will see the hash collision, because the number of files that we deal in digital forensics per case is way smaller than the maximum number of unique hashes that the hashing algorithms can produce. That's why for our case, MD5, SHA-1, or other hashing algorithms are safe to use. But if you are merely looking for encryption purposes, then you need to find out or look into better hashing algorithms. So what are the total or different hashing algorithms uses? We saw that they can be used to validate the data, or to make sure that the integrity is preserved. We can take the hash of the data at the beginning of our investigation, and then later on at different stages, we can compare it with the current file hash, or current artifacts hash, with the original hash. If they match, then it makes, or it tells us that our analysis didn't do anything bad or didn't do any harm to the data. Blockwise hashing can be used in order to find out whether there are still some remnants of a file or not, or whether that file was there on the target file was there on suspect's machine at any given time. Lastly, data discrimination. We can use hashing via data discrimination or KFF database, and it can significantly reduce the amount of time and the amount of files that we need to investigate for any given case. If we have 1,000 files, rather than analyzing or spending our time on all 1,000 files, we will match them or compare them with a known file filter and filter out all the good files, and then focus our energy and time on the known bad files or unknown files. So this way it can speed up our investigation process as well. So the next topic for this lecture is the data hiding techniques. That what are the different data hiding techniques that the suspect might have used, and how we can retrieve the data if we identify a data hiding technique being used. So the data hiding technique, there are a ton of them, starting from or ranging from as benign or as simple, as using features of the operating system or file system, to as complex as editing the fat file system and editing the clusters as of the files as well. So let's jump into them one by one. So the first data hiding techniques that we will see is using the OS or the file system. So if you guys have been using Windows, like previously, you will know that Windows provides the option to hide a file. So if you right click on a file, go to properties, you will see over there that you have the option to hide the file. If you select that, then the file system stops displaying that file whenever you open Explorer. Whenever you see open a folder, if you have hidden files, you will not be directly looking at those files. They will be hidden from the user's view. Another way that you guys have seen a lot in this course is through file extension change. So a user can also, or a suspect can also change the extension of a file in order to hide that file. For example, if I have an image file that I want to hide on my PC, what I can do is change its extension to a PDF file. Now the Windows or the file system will show a PDF icon for that file rather than showing the image icon. So any benign user will not think that it is an image file, and it will just skip that. Another thing is manipulating or changing the name of the file as well. So there are some things, some letters in the file name that you can change. uh, for example, if you have, change 1 with L or L with 1 in the file name from the naked eye, or if you are not looking carefully, those will still look the same. For example, if you have a file called file.txt and another file with the name of fi1e.txt. So if you are not paying attention, that 1 and L, they might look same, and there is a chance that the forensic investigator or anybody who's inspecting the system might skip those files. So here's the screenshot of the hiding files from these documents. So just go right click on any file, go to its properties, and over there you can select this tab over here and hide the files. And here is the example of playing with the name. So google.com and GOO1e.com, they might appear the same if you are not paying attention on the file names. So the next thing is hiding the partition. So not only we can hide the individual files, we can also hide the entire partitions. So it is very easy in Windows. If you guys remember from our previous lab, lab 1, where you had to create a new partition. So every time you create a new partition, you assign it a letter. And if you deassign or remove that letter, then that partition stops appearing in your computer. So let me show you guys the actual demo of that as well. All right. Okay, so as you can see, I have this virtual machine running, and in that I have two drives, C and E. I can store some files or some data in this E drive and then completely hide it from my computer's view. How I can do that? I will go into Disk Manager, and in Disk Manager, you will see that it also shows you the two drives created here, drive C and drive E. I will right click on this drive E and then select this option, which is change drive letter and path. You go here, you see that this drive is assigned letter E. I can just remove it. It is giving me a warning that it will stop appearing in my computer, but that's what I want to do. So I will press yes. And after that, you see there is no letter assigned to this drive right here, but it still exists on my hard drive. So if I go back, you can see that E drive now is completely gone from my computer, but it is still there on the hard drive. And whatever data that you have in this E drive will still there. It is not deleted. It's just not appearing in my computer. So what's the way to recover it back? So you right click over here, go to change drive path and letter, and you can assign it any letter that you want, AE or whatever. So do okay. You can see the letter appears here again. If we go to my computer, just refresh it, you will see that the partition now appears again. So this way, not only you can hide the entire, you can say like a file from the user's view, you can also hide the entire partition. So when as a forensic investigator, you go and you are looking or analyzing a suspect's PC, you have to make sure that there are no hidden partitions. So just go to desk manager and just make sure that all the partitions, they appear in the suspect's my computer. The next technique that we can use to hide the data is by changing the type of the clusters or changing the attributes of the clusters. So if you guys remember from the FAT file system, FAT file system keeps a record of all the clusters that are there on your hard drive, and these clusters are marked good or bad. And the file system tries to stay away from the bad clusters, because the bad clusters are the one that over time now your hard drive is not able to store data on those bad clusters. So the file system avoids those bad clusters in order to store any data, or in order to retrieve any data. So what you can do is you can use tools like Norton Disk Editor. So Norton Disk Editor can go to the file system, or you can say the at the physical level at your hard drive, and then over there it can mark some clusters bad, some good clusters that are actually good clusters, nothing wrong with them, but since we want to hide the data, we can mark them as bad clusters. So for example, if you have a file, say file.txt, and it consists of 4 clusters, what you can do is using Norton Disk Edit, you can mark those clusters that are used by file1 as bad clusters, and now file system will avoid them completely. So since you do that, you are hiding those clusters from the user's view, and even if a user tries to find that file, it will not be able to find it, because the file system, since those clusters are marked bad, it will completely avoid them in search, in access, in writing, and in reading modes. So this is a very high level technique. The easier ones are just hiding the partition or hiding the individual file. But if you want to go one step ahead, you can mark the clusters bad as well. So basically, we are hiding the clusters from the file system's view, and this can also be done. So as a forensic investigator, definitely this will be difficult to find, but you can compare the number of clusters that are on the hard drive and what you see in the file system together. And if there is a very large difference between the number of bad clusters or the number of clusters in the file system versus the number of clusters on the hard drive, then that means there is something fishy, and then you can go, or you can start investigation in that direction. The next hiding technique that we'll be discussing is called bit shifting. So anything that we have, our image files, our text files, music files, video files, so on the hard drive, they are written in the form of zeros and ones, or in the form of bits. So what you can do is we can change these bits, or the sequence of these bits, and this change will be reflected on our data at the high level. So for example, if I have a text file which says, my name is Sayed Ali, that text file will be translated to on the disk level into these bits 1100. So now what I can do is I can shift these bits, or change these bits by moving them towards left, or shifting them towards left, or shifting them towards right. So if I have this file, original file, as 1100, shifting it to the left by one bit means that I remove the leftmost bit, and now the second bit becomes my leftmost bit, and I append a 0 on the right hand side. So 1100 will become 1000. So we are just moving our focus one bit to the left. Similarly, we can do a right shift bit as well. So here 1100, we remove the bit on the right hand side and put it on the left hand side. So 1100 becomes 0110. So this way, using a good hex editor, we can change the pattern of the bits that is there in the file by moving bits or shifting bits towards the left or shifting bits towards the right. And doing this will completely mess up the user view of that file, and the user will not be able to see the content of the file. Let me give you guys a demo of this one as well. So as you can see here, this is a text file, but we cannot see anything in this file, and it looks all gibberish, right? There is nothing to understand, nothing to interpret here. So if we open this file using a hex editor, like here, I have WinHex. How I generated that file is that I have a known good file, which is working totally fine. I went to edit. Let me I select all these files, go to modify data, and then you can see here it is giving me option of left shift bit by one, right shift bit by one, and so on. So if I left shift this bit, you can see this is a demo of bit shifting. It is a clear text that I can see, read. This is my original file. By shifting the bits towards the left by one, the overall representation of this file will change. Now you can see this is how the user will see data, and there is no way for the user to interpret what this file says. But I, as a user, as the creator or attacker, I know that I shifted all the bits to left by one. What I can do is, in order to reverse this change, I can just shift them towards the right by one, and it will reverse that change. So we shifted the bits towards left. Now we want to shift the bits towards right. And if we do that, our gibberish that we see here, it will be now be converted to the actual plain text that we saw. If we shift it towards right by one more, then again it will become unreadable and we will not be able to read this data again. So you can see by shifting the bits towards left or towards right, we can change the representation of the data at the user level. So this ASCII file, if in the pure form, it is shown in the form of, we can read the data in the form of ASCII characters. But if we shift the bit towards left or towards right, by doing that, we can completely change its appearance or change its meaning. So again, I am doing reversing it, and hopefully we'll be seeing the plain text again. All right. So this way, by manipulating the bits, changing them towards left or towards right, we can change or we can alter the appearance of the data that a user can see. And it is like, a very useful technique if you want to hide files. For example, if you have some important document files that you want to, hide from the plain view, or, hide from the other users, you can just use the bit shifting, shift them towards left or towards right by a couple of bits, and then that text file will become unreadable. So this was the WinHex. So the next data hiding technique is called stack analysis methods, or steganography. So if you guys remember from our lecture on the image forensics, in image analysis, we look into steganography. What steganography is? Steganography is the technique of hiding one file inside another. So you have the original file, which we call the cover file, and then inside that cover file, you can hide a text message, you can hide another image file, you can hide another music file, and so on. So there are different type of ways in which the user might have hidden the message, or hidden the data. So what's first of them is stego only attack. So what is stego only attack is that you are investigating a file and you see that there is some stack analysis, steganography done on a file, and you think that some data is being hidden in that file. So in Stego only attack, we just get the cover file or the Stego file which contains the hidden data. We don't know anything about the cover file. We don't know anything about the hidden message. We don't know anything about the tool that the suspect might have used in order to create this Stego file. So this is the most difficult case. In order to do the forensic analysis, we will have to, do spend a lot of time, trying to brute force these techno files, trying to brute force the cover files, trying to guess the hidden files, as well as trying to guess the tool that the user might have used. The next category is known cover file or the known cover attack. So in this type of steganography, we have the stego file, which is the file which contains the hidden text or the hidden part. And we know the original copy of that file as well, original benign copy, which we call the cover file. So if we have our original copy and a copy which has some manipulation done to it, some hidden message stored in it, we can compare them one by one or bit by bit with each other, and we can extract the hidden message part from that file. The third category is known message attack. So in known message attack, we don't know the cover file or we don't know about the steganographic tool that the suspect might have used, but we do know the hidden file or the hidden message in the stegno file. So in this particular case, what we can do is we can look for or search for the bits of the known message in these steganographic files and then extract them from the steganographic file or the stego file. The last two categories are chosen stego attack and chosen message attack. So what is in chosen stego attack is that we know that which steganographic algorithm or tool the suspect have used. We know the original cover file and we know the text message as well. And then our job is that sometimes steganographic tools such as the stag hide, they also give you the opportunity to hide the message with a password and it can only be recovered with the password. So in chosen stego attack, we know all these things like the steganographic tools that is being used, the cover file and the text file. So we can try different passwords one by one, guess different passwords, and hopefully we'll be able to extract the message from the Stegno file. The last category is chosen message attack. So in this chosen message attack, we know the original message and we know its encrypted version or its hidden version. And we try to, reverse engineer the process of steganography, and we try to reverse engineer or find out that what type of hashing algorithm the steganographic tool might have chosen. So in this way, when you are doing analysis, and if you see some stego files or some files that might have been hidden using steganography, these are the 5 cases that you will see. Most of the time, it is known cover attack or known message attack, but you can also see the other ones as well. And out of all these, stag only attack where you don't know anything about the tool that is being used, like stag hive or any other tool that might have been used for creating the stego file, you don't know anything about the cover file, and you don't know anything about the hidden file, is the most difficult one to reverse engineer and the most difficult one to do the forensic analysis. So the last examination that we can do is of encrypted files. So if we find encrypted files on the suspect's machine, then there is only one way to resolve that or to examine that, and that is by breaking the password or breaking the encryption. So there are 3 different things that or steps that we can take at this stage. The first one is we can ask the suspect for the password. If the suspect gives us the password, then we can decrypt the files using that password. The second thing is if the suspect is not cooperating, we can try to break that password ourselves. So in that case, we can use tools like John the Ripper, we can use OPH crack, access data, PRTK. There are tons of other tools available on the internet as well. If you just Google password breaking tools, you will see a lot of different programs and tools that are available. So if the suspect is not cooperating, we can try to break the passwords ourselves. Maybe we are lucky, or we are able to do it quickly. Maybe it takes a lot of time. It depends on the quality and the strength of the password. The other interesting thing is key escrow. Now, a question might come in your mind that what is key escrow? So key escrow is like a bank for passwords. So sometimes, for example, if you have a running organization, People will be using a lot of different passwords all the time. So an organization might have a set of different passwords, right? Say GVSU might have tons of different passwords that they put in on different servers or different machines and so on. So what will happen is that, people usually forget about these passwords. So it is possible that the system admin that knows about all these passwords of, say, GVSU servers somehow forgets some passwords, or resigns from this position, or just quits and steals those passwords and just goes away from the GVSU. So under those type of things, what happen is, like, most of these big organizations or companies, they connect with escrow agents. So escrow agents are basically your bankers, and they give them their passwords, and the escrow agents store their password the same way a bank stores your money. So most of the times, if the company or the organization that you are working for example, like we have taken a case from, say, Citibank, that they want us to investigate their computers, or want us to investigate one of their employees. So it is possible that the employee is not giving us the password. Then in that case, we can reach out to the escrow agent or the escrow agency that might have been working with Citibank and storing all of their passwords. And then we can request the escrow agent to give us the passwords of the employee that we are investigating. So this is not an easy step. Like, you cannot go on the door of the escrow agent and they will not hand you over the passwords easily. You will have to get a proper warrant, or you would have to get a subpoena and follow the proper legal process in order to force, or in order to request these escrow agents to give you passwords for the suspect files or for the suspect machine. So these are the three different ways in which you can break a password or, say, examine the encrypted files. You can look into, you can ask the suspect for the password. If they cooperate, good enough. Otherwise, you can try to break the passwords yourself. If that doesn't work, you can see if the suspect is working with escrow agent, or if suspect's organization is working with the escrow agent, then you can reach out to that escrow agent for these passwords. In that case, you will have to get the proper legal you will have to follow the proper legal channel, and you might have to get warrants or subpoenas in order to get the passwords from the escrow agents. So this is all for this week's discussion. So we talked about different ways in which you can validate the data using hashing, saw different applications of hashing. We looked into different ways the user can hide the data and how we can retrieve that for forensic purposes. And we also discussed a bunch of guidelines or step-by-step process that you need to follow for doing investigation. So if you have any questions about any of these topics, feel free to send me an email and I will try to get back to you as soon as possible.